We're going to take a look at the quadratic formula. Now, the quadratic formula will work to find the zeros of any quadratic equation that's in standard form. So you have to remember that you have to be in standard form before you can use this. You will want to get your flip books out and write this formula down in the tab that you have labeled for the quadratic formula. Okay, we're going to practice using the quadratic formula. Now, if I look at my equation here, 2x squared plus 3x equals 5, I'm not in standard form. I need to subtract the 5 over so I have it set equal to 0. So I'm going to end up with 2x squared plus 3x minus 5 is equal to 0. Now I've got my equation in standard form, so I can go ahead and use the quadratic formula. Now, if you look at your quadratic formula, it says that x is equal to the opposite of b. Well, in my formula, the positive 3 is my b, so the opposite of that would be negative 3. Then I have to do plus or minus the square root of b squared. So I'm going to have 3 squared. Then it's minus 4 times a. Well, in this case, a is our 2. And then times c. And for this one, c is negative 5. Denominator of our quadratic formula says we need to take 2 times a. Once you get all of your numbers filled in there, it becomes a matter of a calculation. So I'm going to start inside my radical, and I'm going to simplify this out. So 3 squared is really 9. Negative 5 times 2 times 4 is negative 40, so I have minus a negative 40, which turns into plus a positive. So underneath my radical, I end up with 49. So I will have negative 3 plus or minus the square root of 49, all divided by, and then 2 times 2 is 4. So at this point, I've simplified the radical, and or simplified what's under the radical, and simplified my denominator. Well, with this one, I can even go farther because this square root of 49 is a perfect square. So I have negative 3 plus or minus 7 divided by 4. And with that, since I have only regular real numbers, there's no square roots, there's no i's, I can go ahead and simplify this all the way down. So I'm going to take negative 3 plus 7, which would give me 4 over 4 is 1. And then I'm going to take negative 3 minus 7, which would be negative 10 over 4, reduces down to negative 5 halves. So my two answers for this one actually turn out to be 1 and negative 5 halves. Okay, here's a second one to try. As you look at this equation, it's not in standard form, so we need to decide which way we're going to move our information since there's 2 terms on the left and 2 terms on the right. I'm going to move everything to the right to keep my x squared term positive. So I'm going to subtract 4x from both sides, and then I'm going to add 9 to both sides. So I would have x squared, and it's going to be minus 6x, because you have a minus 2x and a minus 4x gives you a minus 6x, plus 9, and what I'm left with on the right side is that 0 I need. Then you want to plug things into your formula. Now in this case, b is a negative 6. So when I do the opposite of b, I'm going to have positive 6. Do my plus minus the square root of b squared, so I'm going to have negative 6 squared minus 4 times a. Now in this case, there's no number visible here for an a, which means it's actually a 1. So we have a 1 there, and then my c would be a 9. Divide that all by 2 times a. Now when I go through here and simplify this, you want to be careful because negative 6 squared is a positive 36. Then the 4 times 1 times 9 would give me 36. So I end up with 36 minus 36 in this case, which turns out to be 0. So at this point, I have 6 plus or minus the square root of 0, all divided by 2. Well, now my square root of 0 is also a perfect square. It's 0. So I have 6 plus or minus 0 divided by 2, And again, I ended up with all regular numbers, so I can simplify them. So 6 plus 0 would just be 6 over 2, which is 3. And then 6 minus 0, again, is 6 over 2, which is 3. So in this case, I ended up getting the same answer. I only need to write it once. So for this one, my answer would be x is equal to 3. I only have one answer for that. Okay, here's a third one. Go ahead and see if you can get the numbers subbed into the quadratic formula, and then check back with the PowerPoint before you go on to solve it. So pause the video now. Okay, here's where your numbers should have been subbed in. We would have -1 plus or minus the square root of 1 squared minus 4 times 3 times 15, all divided by 2 times 3. Now when you go to start simplifying this, we're going to have -1 plus or minus, well, 1 squared is 1, and then 4 times 3 times 15 is 180, so we end up with 1 minus 180, and that's going to be all divided by 6. I can simplify this a little bit farther, so I'm going to have x equals -1 plus or minus, well, when I take this 1 minus 180, I get -179, and that's all being divided by 6. Now there's a couple of things that we need to notice here. 179 is not a perfect square, so I'm going to have to work with it as a square root. And the second thing is there's a negative under the square root, so I have to take care of that problem too, because we can't leave that negative there. So I'm going to leave that -1 plus or minus alone. Now remember, when you have a negative square root, it breaks down into the square root of -1 times the square root of whatever your number is, and then that square root of -1 is I. So instead of the square root of -179, we're going to have I square roots of 179 over 6. Then you want to check if you can break down 179 using any of the perfect squares. And for this particular one, we can't. But now to be in standard form, since I have an imaginary number here, I need to separate my fraction into a real part and an imaginary part. So I'm going to have -1 over 6 plus or minus